All right, so we're talking about our chapter 2 regression assignment. So this is pretty much your end of chapter project. Um, and it's going to be worth about 50 points, I believe. It's pretty much going to be your test, okay, for chapter 2. And as I mentioned, this is going to be due by Sunday midnight, 11:59 specifically by Sunday. So you'll have the rest of class today after I'm done explaining it, and you'll have Thursday in class to work on it. You'll have the Friday asynchronous day to work on it, and then you'll need to submit it by Sunday. But quite honestly, it really doesn't take that long to do. I just want to give you guys enough time in class to work on it because I know some of you have other things that you're dealing with at home. So I didn't want to make it part of homework. Okay. Um, so let's talk about our directions here. So first thing we're going to do is we want to make sure we read through the directions carefully, and we want to make sure we understand what exactly is being asked of us. Okay. So I want you guys to read along with me, and on your paper, make notes. If I mention anything specific that's not necessarily in the directions, make notes for yourself on the direction sheet so that you are um, able to, reference back to it later on. So the first thing you're going to do, okay, the first thing you're going to do is you're going to select one of the data sets to work with. Okay. So one of the data sets, we have multiple data sets here. So you're only selecting one of the data sets. Okay. Um, wow, we're trickling in, I guess. Okay, so you're only selecting one of the data sets to work with. You're not doing all of these. So you can choose to do the bald eagle population from 1963 to 2006. There's the world record times for men's outdoor 1,500-meter run between 1957 and 1983. Don't choose number 2. This is the one I'm going to do an example of. Okay, so you cannot choose number 2. Please make a note of that. You cannot choose number 2 to work with because I'm going to do that as an example. Okay. Number 3, federal surplus deficit years 1998 to 2011 in billions of dollars. Number 4, Apple stock price per year from 2001 to 2012. We can probably add on to that too. Number 5, Facebook members by year 2004 to 2011. Number 6, total album sales by unit. Number 7, total CD sales by unit. Number 8, total vinyl LP sales by unit. Total cassette sales by unit. So we have a lot of different stuff. Number 10, the median US income. Okay, number 11, total US healthcare expenditures. Okay, 1960 to 2010 in billions of dollars. Number 12, number of participants in skateboarding in the United States from 2006 to 2013. Okay. 13, minimum wage in California. And we can see that spans 100 years. So 1916 to 200 or 2016. So that spans 100 years there. That's actually pretty cool. And then 14, iPhone sales by year, 2007 to 2013 in millions. And we could probably add more data to that too. But you can see you have a variety of data to choose from here, and you're just going to choose one set of data. Okay. So then you're going to clearly identify the 2 variables. Okay. So what are the 2 variables in the data set? And you're going to specify which will be the input, aka the X, right? And which will be the output, aka the Y. And so you're going to identify the two variables and you're going to specify which will be the input and which will be the output, the X and the Y. Next, your thing you're going to do is you're going to graph the data as a scatter plot on a poster board. So you're not going to do this as a poster board, obviously. I'm going to create like a Google Slides that you guys can paste your work into. Okay. So, but you're going to have to create a graph graph the data as a scatter plot. Now, since this is digital, we could probably do this digitally, right? So you could probably use Desmos to do that, or you can graph it by hand. Either way, I need to be able to read the graph and I need to be able to see the graph. You could also do this in Excel, where you put in your data and you create a scatter plot, okay? So you want to make the graph as large as possible so that we're able to see the data and where the data points are, okay? I want to make sure, yeah, there we go, okay. And then once you graph your data, you're going to make a prediction. So you're going to make a prediction. What type of function will best model the data? Linear, exponential, quadratic, or maybe it's something else. Maybe it's something we haven't discussed yet, right? It could be cubic function. It could be a quartic function. It could be a logarithmic function. You know, whatever. Maybe if you think back to the types of graphs that we've looked at in the past, right? Think back to 2.0 and all the different parent graphs, okay? And then, of course, justify why you think this way, okay? This, I want you guys to understand this part. This should not be supported by calculations. It should be based off of your observations of the graph, okay? So don't tell me I think this because R squared is best. You shouldn't have done calculations in step 4. Step 4 is only a prediction. And a prediction can either be right or wrong, but that doesn't mean if you made the wrong prediction, that doesn't mean you're wrong. It's your prediction, it's your thought. As long as you're justifying it with a valid justification, like, oh, I think it's quadratic because it goes up and then it curves down, or it goes down and then it curved back up. So I think it might be quadratic. So something like that, like how we were justifying exponential versus quadratic, where we were using the steepness, the slope of it, we were using the shape of the data, and something as simple as linear, like, right? I think it's linear because it looks like a straight line. Like the pattern looks like it's moving in a straight, constant line. So, okay, there you go. That's your justification. Okay, that it doesn't need to be fancy, honestly. And then number 5, you want to do at least 3 regression models to fit the data, okay? We learned 3 regression models. We did linear, quadratic, and exponential, but you're not limited to those 3. Like I said before, you can do logarithmic, you can do cubic. In your calculator, there's a lot of different types of regression, okay? And we'll talk about that when we go back to the Elmo real quick. But there's a lot of different types of regression, so you're not limited to just the 3 that we've discussed. Okay, so as I say, you can use linear, exponential, quadratic, indirect variation, so like a ratio or rational function, or some other type of function you wish. Use a graphing calculator to find the functions for each model. So you're going to do a regression on your graphing calculator, or if you haven't picked up a graphing calculator yet, then you're using meta calculator. Graph each regression model on the same scatter plot, okay, using different colors to distinguish between them. So what the scatter plot that you made up here in step 3, you are then going to graph those regression models on that same scatter plot, okay? And I want all 3 models on the same scatter plot. So in the end, I should be seeing one graph, right, with all 3 models on it. And then I also want you to create a key to identify which regression model goes to which graphed model. So which one is which. I need you to identify, like, give me a key for it, right? Because I say use different colors, and I need you to tell me which one each color represents, what kind of function, which regression, okay? And then find the residuals for each function, aka find r squared, and plot them all on one coordinate plane using a different color for each function. Okay. Using the residuals, determine which function models the data most appropriately. That's number 7. And then number 8, use your best model to predict a future value, such as the output 10 years from now. Okay, and then of course, number 9, answer the reflection questions. So the reflection questions are not attached, so I will get those for you. I apologize. I will get the reflection questions for you. They are not attached here. But you will answer the reflection questions as a number 9 as your final step here, okay? So if we come to our Elmo here, right, I have the same thing. I have the same exact chapter 2 regression model. And remember I said you can't do you can't use data number 2 because I'm doing my example with data number 2. So number 2 is out. Can't use it, okay? So step 1 was to select the data set, done, okay? Step 2 is to identify my 2 variables, specifying which will be the input and which will be the output. So if I take a look here, okay, I have world record times for men's outdoor 1,500-meter run between 1957 and 1983. So as I can see, I have 3 columns here. I have the year, I have the runner and the country, and then I have the time in seconds, okay? Now, the runner in the country, it's not numerical. So I can't really use that as a variable for a regression model. So the runner in the country, it's cool to know, but it's not really gonna help me in my regression. So my 2 variables are gonna be year and time in seconds, okay? So my year will most likely, I'm going to choose my year to be my X variable. Okay, so that'll be my input. Okay, and then I'm going to choose the time in seconds to be my output, my Y variable. Okay, so this will be my X and this will be my Y right here. Okay, so then how are you going to describe that to me? Well, you're going to go ahead and write it in. So you remember how in the past I've said, you know, if you're dealing with years, you may want to like modify it so that you're not putting in, you know, 1957, like you're not putting in 1057, because that makes your numbers a lot larger to work with or a lot smaller. Like you might be working with a lot of decimals. So it's always great to like modify it into, you know, the number of years from, the number of years from a specific year. So this starts at 1957. So I can start it at 1957, or I can pick a nice round number like 1955. So it really depends. You're the one defining this, right? You're the one defining what year you're using it from, or so you're the one deciding. So I'm going to decide 1955. Okay, so I'm going to make my X. Okay, I'm going to make my X here. Where is it? There we go. I'm going to make my X, my inputs, the number of years from 1955. And I'm going to make my Y, the outputs, my time in seconds, okay? So then number 3, right? I've already done this example, so I'm showing you what I've done so far. Number 3 was to graph on an entire graph paper, graph the data as a scatter plot, okay? So what you're going to see, what I'm going to show you right now is the completed project. But once you graph it, let me zoom out here. Okay, Once you graph it, notice I took up the entire graph paper, which is what I was explaining for you to do. I took up the entire graph paper. My X is labeled number of years from 1955. And I even went as far as to like label what actual year that is underneath the number, but you don't have to do that. Okay. My Y is my record times in seconds. Okay. And I have it even broken down, right? And I try to make it as minute as possible because my data in and of itself, my data includes decimals. And so I wanted to make my graph in a way where I can show my decimals. Now, I could have just done 2010, 2011, 2012, 2013, 2014, 2015, 2016, all the way to 2019, and I would have only gone this high up on my Y. But if you pay attention to the directions, okay, if you pay attention to the directions, it says on an entire graph paper, okay? And I be careful, pay attention to the scale because I want you to take up the entire page. So make sure that when you're graphing this, whether it's by hand or on a device or some sort of electronic tool, that your graph and the scale of your graph allows for us to see the detail of the data. So like if you were to do this, you would have to make sure that you are zoomed in enough. So for example, if I go to, let me go to Chrome real quick. And if I were to go and use Desmos, okay. So if I were to go to use Desmos, how do you put points on a Desmos graph? Well, you literally just put your points. So 2, comma, I'm just going to put in my data. And the 2 obviously is coming from the 1957, right? Because 57 is 2 years from 55. So I've already kind of modified my data. And obviously you're like, where the heck did the point go, Miss K? Well, there it is. Okay. But it's going to be really difficult for you to modify your graph this way because of this number here. So I don't know, you're going to have to, I have a feeling, I want to say I want this done by hand. Do we all have graph paper at home? Can you give me a yes or a no? Yes, if you have graph paper at home, no, if you do not. Aaron, Kelly, can you guys respond? Zahn, can I get a response from you? Yes or no? Do you have graph paper at home? Okay. So you guys are gonna have to use Desmos to do your graphing then for most. If you have graph paper at home, I would appreciate it if you did it by hand, but I'm not going to require it because the majority of you guys do not have graph paper at home. If we were in class, obviously I would be giving you graph paper, but that's not the case. Okay. So at this point, I'm just putting in my points just like this. Okay. And I have 2 of the same point. Interesting. Okay, and then 25, comma, to 11.36. And then I have here 28, comma, to 11.23. and then another 28, comma, 210.28. Okay, so here are all of my points. Obviously, you're not able to see that right there, right? So there is a way you can actually modify this. So you see how you have your, if you click on the little wrench here, it's like graph settings, okay, you can actually modify your X and your Y axes intervals. So my X, I can just literally change to 0. Okay, and for the X, let's say I went all the way up to 28, so I'm gonna go up to 30 here. So look what that automatically did. That legitimately changed it spaced out my X's right there. Okay, so you guys can do this on the Desmos, and I expect you to do this part where you are giving me the best possible. Now, over here though, it looks pretty mono thing because all of my points, all of my times are like, it's between 212 and 210. And so it looks pretty like horizontal, but I want to see a more detailed graph here. So what I can do is, again, on the graph, now I can change my Y. And I'm actually going to change my Y to exclude all of this that I do not need. I don't need 0 to 200 here. I don't. So I'm actually going to start my Y from 200. And then I'm going to take it to 220. Okay, so I want to show you, right? On my graph, I'm going to stop sharing this for a second. On my graph, this is exactly the intervals that I pretty much had here. If you take a look at my graph here, my hand-drawn graph, right? My X was 0 to 30. Okay, and my Y was like, I even did 210 to 219. But this one I did 200 to 220, right? So I even focused it in a little bit more on my graph. So I can do that here for Desmos as well. So going back to my graph, I can actually make this 210 to 220. And every time I zone in a little bit more, right, I get more of the shape of how my data was moving here. Okay, so I see a bit more of the shape of how my data was moving here. And so this can look like, so once you have your graph, right, once you have your graph here, I want you guys to take a screenshot of this. Okay, so you can actually zoom out just a tad so you can see your graph. But so you don't see your x-axis with this though. That's the problem. Oh no, you do. It's right down here. So make sure you guys grab that part as well when you are sharing this. Okay, make sure we're able to see this part. So you can grab a screenshot of this and you'll paste it, but you'll also need to label your X and Y axes using text boxes on your Google Slides, okay? So make sure you label your X and Y axes here. So from here, you're gonna screenshot this. This is gonna be your scatter plot. And then you're gonna make your prediction, okay? So you'll make your prediction as to which function you feel like would fit this the best and why. So complete sentences, guys. So this data looks like it could be modeled by a linear function because it is decreasing at a constant looking rate. It looks like it's decreasing at a constant rate, and there doesn't seem to be a strong curve. Okay, so that's my prediction. I don't know if it's right or wrong. Okay. And then you're going to do 3 different regressions. So I did linear, quadratic, and exponential. Okay. So when you do the 3 regressions, right, then you're going to graph them. So your 3 regressions, here are my hand graphed regressions. Okay. With your Desmos, you're going to then For Desmos, you're going to come in and you're going to just, wait, let me share my screen. I don't think I did. You're just going to come in and you're going to put in your functions. So if I use the same functions that I had from before, okay, so I have y equals negative 0.227x. This is my linear, plus 217.072. Okay, that's my linear regression. My quadratic, I have y equals 0.0073x squared. Okay, minus 0.444x. Oops, there we go. Plus 217.938. Okay, there is my quadratic. I feel like
You put an addition sign rather than a subtraction.
did I? Thank you. I'm like, why isn't that working? And for which? For the minus? No, here in the middle. Got it. Thank you. Ah, you're a blessing, Oswaldo. And then y equals 217.08. Oops, wrong mark. And then parentheses 0.999x. Oh, no, that's an exponent of x. There we go. All right. So here are my different models. And of course, at this point, I would expect another screenshot from you. So from here, I expect another screenshot. So you can take a screenshot from here all the way down so that the x-axis is included all the way across. Okay, so with all three of these, and then on the Google slide, I do expect a text box for a key saying, you know, the red is my linear function, the blue is my quadratic function, the green is my exponential function. And then on your like on another slide, you're gonna then give me the actual linear function. Like you're gonna give me the functions themselves. Like you're gonna actually list them like this, like I have in my paper. So you'll write this in, and then you're gonna talk about the residuals. Okay, so you're gonna give me the R squareds. You're gonna list the R squareds for me. And then number 7, you're gonna give me you're gonna determine, okay, which function models the data most appropriately based on R squared. So you're gonna continue with writing a sentence about that. And then you use your model, your best model to predict a future value. So once you've determined which one of these models is the best, which I apparently did not finish this, I do apologize for that. Once you determine which model is the best based on R squared, you're then going to plug in, and this is the 10 years is just an example, but that's not, it doesn't stop you from using it. So suppose like my linear function, right, was the best model. 10 wouldn't work here, right? Or actually it would because I don't have a 10-year mark. But so I could do 10. Or considering the fact that it ended at 28 years from 1955, I could do like 40 years from 1955. Or I could figure out how many years 2020 is from 1955, and I could get that data in here. So I could plug in 20 years from 1950, I'm sorry, 2020 from 1955 is 65 years. So I could plug in a 65, right? So whatever prediction I want to make. Okay, so you can make one that's missing from your data, or you could make one that's like in the future from your data. So you're going to make that prediction, and then I'm going to get these reflection questions up for you on Thursday. So then you'll answer the reflection questions, or I'll have them in the Google Slides. How's that? I'll have them in the Google Slides for you. Okay. Any questions on the expectations of this project? Okay, of this assignment here. Okay. So if you do end up having questions throughout as you're working on it, please do not hesitate to ask them. Please make sure that you're getting your questions answered so that you can turn this in. This is worth a lot of points in the test category. You do not want to not do this assignment. I'm giving you class time, okay, today, Thursday, Friday. You are being given a total of like 4 hours to work on this in class. Shouldn't take you anywhere near that much time. Um, but I'm trying to give you guys all the opportunities that I can to help you guys. And we're going to be doing it during class so that if you have questions, you can ask them and I will answer them. Okay. So we're here. I'm here. Uh, One thing I do want to for you to do before you leave class today is I want to make sure that you have chosen a data set to work with because I do not want I want everyone doing a separate data set, considering the fact that we have a total of, how many was it? Oh, wait, there was more here. Oh, there's two more on the back that I did not see. Data of fertility rates versus life expectancy and heights and weights of baseball players that I did not see here. So we have plenty of data to choose from. Okay, so yeah, I didn't even scroll past this page, but why? Why didn't it scroll past this page? That is odd. So what, number two? V2? Is that what you're asking for?
Yeah.
Number two is just identifying the two variables. So in your data set, like for my data set here, right, I identified my two variables. So I have 3 columns here, but runner and country are words. It's a categorical variable, so I can't really use that in a linear or in a regression. So my two variables are year and time. So the input is usually your X, the output is your Y, right? So I chose the year to be my input, so that's my X variable. And I chose my time in seconds to be my output, that's my Y variable. So I defined my variables here, if you can see on the Elmo, on this guy, I defined them, right? So if you're gonna modify your years to be like the number of years from a certain year, then you wanna make sure you define that. So I put my X, which is my inputs, is the number of years from 1955, because my data set started at 1957. So I wanted like a nice, you know, rounded number. So I did number of years from 1955 for my X. And then for my Y, my outputs, I did the time in seconds. So my Y didn't really change. It's just you're defining your variables. You're telling me which one is going to be your X and which one's going to be your Y. And if there's any modification in years, then you want to make sure you define that.
Thank you so much.
Yeah, no problem. Okay. So there you have a bunch of data sets here for you. I'm wondering if the one that I posted for you has the last two data. Do you guys have a data set 15 and 16?
No, it only goes up to 14.
It only goes up to 14. Okay, so that's fine. I took away one, so that's 13. There's 12 of us in the class. Each one of us needs to select one. Okay, I don't want anyone doing a duplicate of another one. So before you leave today, you need to choose a data set, and you need to let me know, and it's first come, first serve, honestly. So if you see a data set that you want to do, let me know as soon as you decided. And that way I can, yes.
Can I do the iPhone sales over here?
iPhone sales, hold on, number
14.
Can you guys do me a favor? Write it publicly in the chat. Write it publicly in the chat. That way the rest of your classmates are also privy to it. Okay, so Nick took 11, Oswaldo's taking 14. So this is Oswaldo. Okay, and then Nick, this is Nick. Okay, Juan is calling number 4. Okay, so it's gonna be JE. V2 wants number 1. Okay. Zon wants number 12. Absolutely, number 12. So CG. Let's see. Hold on, trying to catch up here. Mordecai. Kai wants number 8. Okay, so that's going to be KG there. William wants number 3. Ariana wants number 9. Aaron wants number 6. All right. Okay. Right on so far. So so far the available ones are number 5, the Facebook members. Number 7, the total CD sales. Number 10, the median U.S. income. Number 13, the minimum wage in California. So these are the ones that we have left to choose from. So again, before you leave today, you must choose your data set. Anthony, oh, here we go. Lumeria wants number 5. Okay. Okay, that's Lumeria. And then Anthony wants number 13. Okay. All right. So I have not heard from Kelly, I think. Kelly has not chosen one yet. So Kelly, your options are number 7 or number 10. Okay, your options are number 7 or number 10. Okay, number 7. All right. So I believe we've all chosen one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. All right. So let's all get started on our work. Okay, remember Desmos is your friend, and if you do not have a graphing calculator, Meta Calculator is your friend. But if you do have a graphing calculator, as I was saying here, when you go to calculate, you have a lot of different options for regression. Linear, quadratic, cubic, quartic. Okay, and then natural log, that's LN regression, number 9. Exponential regression, that's 0 there. A power regression. Oh, my bad. Power regression, logistic. So sine regression is like trigonometric regression. You don't want to do that one. Okay, so you want to do linear, quadratic, or cubic, quartic, exponential, and you could even do the natural log regression if that's something you wanted to try out. Okay, so yeah, test each one of those out, check it out. And again, just a reminder, if you're going to edit your data set, you're going to go to Stat, Edit, and if you want to erase what's already in there, remember, you go up to the title of the list, hit Clear, go down, and it clears everything. Okay, so once again, up to the title of the list, hit Clear, go down, and it clears everything up for you. Okay. All right, ladies and gents, I'm going to be quiet now and let you guys get started. I am here. If you have questions, please do let me know. Okay.